Today we'll be solving the shortest distance from surface xy plus 6x plus z squared equal to 33 to the origin 0, 0, 0. So first of all, let's visualize this. Imagine we have a curved surface in this 3D system. And at certain point on the surface, we'll have the shortest distance. And we draw a vector from that point towards the origin. And this vector will be the normal vector, or it's perpendicular to the tangent plane of that point on the surface. And this vector will have a length d. Recall that in a 2D system, by Pythagorean theorem, we have d squared equals to x squared plus y squared. And similarly, in a 3D system, the square length of the vector will be d squared equal to x squared plus y squared plus z squared. And how can we relate that equation to our problem here? What we can do is to rewrite the surface equation at z in terms of x and y. So z squared will be 33 minus xy minus 6x. So we can plug the z squared into the distance equation. And distance will be a function of x and y. So d squared will be equal to x squared plus y squared plus 33 minus xy minus 6x. Because we're finding the minimum distance, which is an extrema of the function f of x and y. So we're going to find the gradient and set it to 0. So fx would be 2x minus y minus 6. And fy would be 2y minus x. And we set them to 0. And that gives us 2x minus y equals to 6. And 2y equals to x. So we label them as first and the second equation. And then we can substitute x equal to 2y into the first equation, which gives us 4y minus y equals to 6, which is 3y equals to 6, and y will be equal to 2. And plug in y equals to 2 into the second equation, we have x equals to 4. So now we have our x and y coordinates, and now we're going to find the z coordinate. By using the modified equation of the surface, we can plug x and y in. So z squared equals to 33 minus 4 times 2 minus 6 times 4, which equals to 33 minus 8 minus 24. And that gives us z squared equals to 1. Because we take the positive value here, z equals to 1. Now we have obtained all the information of that point where the vector connects to the origin. We can write the distance as square root of x squared plus y squared plus z squared. By plugging in the x, y, z values, we have square root of 16 plus 4 plus 1. Then the shortest distance from the surface to the origin will be square root of 21.